Hello students, now we start the numerical of current electricity, class 12. Numerical of current electricity. Our first numerical is when a potential of 5 volt, suppose this is length, potential between these two 5 volt. A is the area of cross section. When a potential of 5 volt, question, when a potential of 5 volt is applied across a wire of length .1 meter, the drift speed of electron is 2.5 into 10 to the power minus 4 meter per second. If the electron density it means number of electrons per unit volume is 8 into 10 to the power 28 per meter cube. Calculate resistivity of the material. This is our question. Solution. Here L is how much? 0.1 meter. 0.1. Power 28 per meter cube, and VD drift speed 2.5 into 10 to the power minus 4 meter per second. Since we have to find out value of resistivity, we know R equal to rho L upon A, and I equals NEABD. Second, and V is equal to IR. So here R is this one and I is this one, and V is given there. Put these values. I equal to NEABD into rho L upon A. This A is cancelled out. Remaining values NEABD rho into L. We have to find out this rho. Then rho equal to V upon NEBD into L. NEBD L. And V is given 5 volt. This one. 5 volt. Put all these values in this equation. 5 upon and how much? 8 into 10 to the power 28 E equal to 1.6 into 10 to the power minus 19 into BD equal to 2.5 into 10 to the power minus 4 and L equal to 0.1 meter, 0.1. Then calculating this one, 5, 8 into 1.6 into 2.5 into 0.1 into 10 to the power 28 plus 19 minus 4 minus 28 minus 19 minus 4. It means 23, or we can write 5, 8 into 16 into 2.5 into 1 into 10 to the power 5. This one 10, this one again 10, this one again 10. Now, then this becomes 5 5s are 25. Then 1000 upon 40 into 16 into 10 to the power 5. Here rho equals 10 to the power 3 into 10 to the power minus 5 upon 40 into 60. It means 10 to the power minus 5, or we can write here 1000. 1 0 is cancelled out. 100 upon 64. This is equal to 1 point. How much? Its value comes 1.5 into 10 to the power minus 5 ohm meter. This is the answer. Once again, our question is a conductor, its length is 0.01, L equal to 0.1 meter. Length is 0.1 meter. Voltage applied across it 5 volt. Number of free electrons per unit volume is 8 into 10 to the power 28 per meter cube. And net velocity 2.5. 2.5 into 10 to the minus 4 meter per second. Resistivity is to be found out. Resistance formula R equal to rho L upon A. Net velocity, relation between the current and the net velocity is given is V equal to IR. We put the value of R and I and put the values, then that is the answer. Next question. Question number 2. Our second question is a cylindrical metallic wire it is stepped to increase its length by 5%. Calculate the percent change in resistance. It is our question. Initial length is, suppose this one. A1 is the area and L1 is the length. It is step 5%. Then length becomes L2 and area becomes A2. The volume of the material remains the same, but length is increased, then the cross section is decreased. Here L2 is solution. Let initial length L1 increase length L2. Then L2 is equal to L1 plus 5% of L1 is increased. It becomes 105 upon 100 L1 or 21 upon 20 L1. This is L2. Now, volume is equal to L1 A1 and L2 A2. It remains the same. Then A2 L2 is equal to A1 L1 or A2 upon A1 is equal to L1 upon L2. A2 upon A1 is equal to L1 upon L2. L2 is equal to L1 upon 21 upon 20 L, or it is 20 upon 21. It means A2 upon A1, L1 upon L2 is equal to 20 upon 21. Now, R1 is equal to rho L1 upon A1 according to the formula of resistance, and R2 is equal to rho L2 upon A2. Resistivity is the property of the material, it remains the same. If we divide equation second by first, divide equation second by first, then R2 upon R1 equals L1 upon A1, L2 upon C2. Sorry, L2 upon A2 rho or rho L1 upon A1. Rho is cancelled, or here L2 upon L1 into A1 upon A2. This L2 upon L1, A1 goes in the numerator and A2 goes to the denominator, and this is cancelled out. Now values of A2 upon A1 and L1 upon L2. R2 upon R1 equal to how much? Or we can write it A1 upon A2 is equal to L2 upon L1 is equal to 20 upon 20, 21 upon 20. In reverse, to get these values. So L2 upon L1 is 21 upon 20, and this is A1 upon A2 is equal to 21 upon 20. It is 441 upon 400. Or R2 is equal to 441 upon 400 R. Change it, percent change. R2 minus R1 upon R1 into 100. Then 441 upon 400 R1 minus R1 upon R1 into 100. this comes 441 minus 400 upon 400 R1 upon R1 into 100. This is cancelled out. It means 41 upon 400 into 100 upon 4 divide 0 to 5%. It means R2 minus R1 upon R into 100. This is our answer. Change in percent change in the resistance is 10.25%. Once again, question is, a cylindrical metal wire is stretched to increase its length by 5%. Calculate the percent change in resistance. We consider initial length is L1, this one, and initial cross section is A. A1 and final cross section A2. A1, A2 are the cross section before and after stretching. L1 and L2 are the length of the wire before stretching and after stretching. L2 is 5% more of L1. Then L1 plus 5% of L1 comes this one, and this is the value of L2. According to the dimension, the volume remains the same. Multiplication of cross section and length gives the volume. This is the initial volume, this is the final volume, but these two volumes are equal to each other. So we can find this relation. And R1 is equal to such one, R2 is equal to such 2, divide R2 by R1, you get this one, and put the value L2 upon L1 and L1 upon L2, 441 upon 400, percentage change, we calculate this and that comes to the answer 10.25. This is our lecture. Okay, now we finish. Okay.